Hello everyone. Today we will discuss about UV spectroscopy. UV spectroscopy deals with the measurement of energy absorbed where electrons promoted to higher energy levels. UV spectrum is the plot of lambda of light absorbed versus absorption intensity, or we also show absorption spectrum by plotting molar absorptivity and wavelength. A molecule contains electronic, vibrational, rotational level. Electronic transition includes in UV and visible region, vibrational and rotational. These are included in IR and microwave region. UV spectrum involves electronic transitions accompanied with the vibrational and rotational states because larger amount of energy associated with UV radiations. A record of the amount of radiation absorbed or transmitted by a given sample as a function of wavelength of radiation is called absorption spectrum. One expects a single line, but actually spectrum is made up of absorption bands with peaks of maximum intensity. UV spectrum divided into far, near, visible region. Far or vacuum UV region, it includes 10 to 200 nanometer. The atmospheric absorption below 200 nanometer. When electrons in sigma bond excited give absorption in the range 120 to 200 nanometer. It is difficult to measure and little diagnostic value. Near or quartus UV 200 to 380 nanometer. This mainly cover UV region. Excitation of electrons from p and d orbitals, pi orbitals and conjugated pi orbitals occurs about 200 nanometer. It is informative spectra. Visible region, it involves 380 to 780 nanometer region and 200 to 800 nanometer. It is referred to as UV, although includes visible region also. Selection rule for the electronic transition. Symmetry forbidden and spin selection rule. Symmetry forbidden means electronic transition occurs in the symmetrical orbitals when non-bonded electrons transfer to pi antibonding orbital. There is change in symmetry, and this is symmetry forbidden transition. Electronic transition for spin selection rule, change in the spin is not allowed, means singlet to singlet or triplet to triplet. These are only allowed transition, and singlet to triplet or triplet to singlet are not allowed. Electronic transitions, these are the electronic levels. Main electronic transition occurs in these 4 transition: sigma to sigma star, non-bonding orbitals to sigma star, pi to pi star and non-bonding to pi star. Electronic levels are sigma bonding, pi bonding, non-bonding, sigma star and pi star and sigma, pi antibonding and sigma antibonding orbitals. These are orbitals. सिग्मा बॉन्ड्स आर द लोवेस्ट एनर्जी ऑक्यूपाइड मोलिकुलर ऑर्बिटल, इनको LOMO बोलेंगे. पाई ऑर्बिटल्स हाइयर एनर्जी, नॉन बॉन्डिंग लोन पेयर ऑर्बिटल्स एंड देन अनऑक्यूपाइड और एंटी बॉन्डिंग सिग्मा और पाई स्टार ऑर्बिटल ऑफ हाइएस्ट एनर्जी. दीज आर कॉल्ड होमो. ट्रांजिशंस mainly from sigma to sigma star. These are involves 120 to 200 nanometer. Only sigma bonds in the molecules. For example, saturated hydrocarbons. For example, methane it show absorption in at 125 nanometer. Pi to pi star, these are multi bonds. For example, aromatic hydrocarbons, carbonyls, azo group, these are also present in the pi bonded molecules. But ethylene show at 180 nanometer. This absorb in the far UV region. This is due to there is conjugated double bond, absorption occur in the longer wavelength and energy is lowered. For example, butadiene, which absorbed at 217 nanometer. Molar absorptivity for pi star transition is very high. E maximum is greater than 10,000 or 10 raised to the power 4 because pi and pi star orbital situated in same plane. Hence, probability of jump of electron from pi bonding orbital to pi anti-bonding orbital is very high. Non-bonding to pi star transition, for example, carbon and chlorine. Chlorine, there is lone pair of electrons. Non-bonding electron at heteroatom and greater electronegativity of heteroatom, more tightly non-bonding electrons. अगर हेटेरोएटम की इलेक्ट्रोनेगेटिविटी ज़्यादा है तो नॉन बॉन्डिंग इलेक्ट्रॉन्स टाइटली हेल्ड होते हैं. Hence, more energy required for transition. Therefore, these are not of much importance. Non-bonding to pi star, double bond between two heteroatoms, non-bonding electrons. For example, CO, C double bond S, N double bond O, N double bond N. These show weak absorption. For example, aldehyde and ketone exhibit two bonds, more intense at 180 to 200 nanometer to pi and pi star transition and low intensity band at 200 nanometer. These are non-bonding to pi star. Non-bonding to pi star transition are weak. Non-bonding orbital are perpendicular to the pi star orbital and jump electron is low due to symmetry selection rule. Non-bonding and pi anti-bonding orbital are not symmetrically allowed.